Students, welcome to the subject software engineering. Today we'll continue with our topic, that is design concepts. So today we'll study refinement, refactoring and design classes aspects as related to design concept. First we'll take refinement. Students who are studying design concepts, in this refinement is very important factor. Point number 1, stepwise refinement is top-down design strategy. Students, this refinement is nothing but improving the quality of the design. So here you have to go by top-down design strategy. Point number 2, a program is developed by successively refining levels of procedural details. So here, how you are going to develop the design. So in every cycle of refinement, improvement is done. Point number 3, a hierarchy is developed by decomposing a macroscopic statement of function, that is a procedural abstraction, in a stepwise fashion until programming language statements are reached. So students, when you design a software, you write the programs or you have overall design. So here that overall design or macroscopic statement should be broken down into various small statements which result into a program language statement. You very well know that program language statement should be very straightforward and it should result. So hierarchy is developed by decomposing macroscopic statement of function and the result is stepwise programming language statements. Point number 4, refinement is actually process of elaboration. Students, refinement means what? Whatever abstraction is there, that is put in detailed manner or that is elaborated. So the steps are increased, minute steps are written down. Point number 5, abstraction and refinement are complementary concepts. So in abstraction you very well know that minute details are avoided and only important concept is taken, whereas in refinement you are going for minute concept, minute steps which will result into a answer. Point number 6, abstraction enables designer to specify procedure and data and yet suppress low level details, whereas refinement helps the designer to reveal low level details as design progresses. So abstraction and refinement are opposite of each other. That is, in abstraction you suppress low level details and only take important procedural matters, whereas in refinement minute low level details are identified. Point number 8, both concepts aid the designer in creating complete design model as design evolves. So both abstraction and refinement are important from the development point of view. Next, we'll go to refactoring. Refactoring, point number 1, is reorganization technique that simplifies the design or code of a component without changing its function or behavior. It is important design activity for many agile methods. Students, you very well know refactoring. Refactoring means means once again, factoring means divided into smaller components. So refactoring is nothing but reorganizing technique that will help us and simplify the design of a component without changing its external behavior or function. And it is very true in the old software development technique. Point number 3, refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, yet improves the internal structure. So refactoring is nothing but it is a process where you change the software system so that the external behavior remains the same, but the internal programs are improved. Continuing this refactoring, point number 4. When software is refactored, the existing design is examined for redundancy, unused design elements, inefficient or unnecessary algorithms, poor data structures, or any other design failure that can be corrected to yield a better design. So when you go for refactoring, you examine the present design, whether there is any redundancy. Redundancy will cause lot of storage space and time, and if there are some unused design elements, those should be removed. Inefficient or poor algorithms should not be there, so that it will take more of space and even the processor time. Poor data structures also are not efficient, so hence you should go in for better design where refactoring is helpful. The result of refactoring will be software that is easier to integrate, easier to test, and easy to maintain. Next we will go to design classes. Point number 1. As the design model evolves, the software team must define a set of design classes that refine the analysis classes by providing design details that will enable the classes to be implemented, and second, create a new set of design classes that will implement a software infrastructure to support the business. So when you are going in for design, you should think of the designing the classes in such a way that will help you to refine the classes that you had thought during analysis process, so that we can implement them in design. Also, if there is any necessary, you can go in for new set of design classes. Point number 5. Point number 2, that is 5 different types of design classes are suggested, each representing a different layer of design architecture. So we'll try and know what are the 5 design classes. One is user interface class. So the user interface class define all the abstractions that are necessary for human computer interaction. So one has to interact with the computer, so how the human can be very easily interact, that is defined by user interface classes. Business domain classes, these are often refinement of the analysis classes defined earlier. The classes identify the attributes and services that are required to implement some element of the business domain. So business domain classes are very important, and they will help you to identify the attributes and services that are required to implement some elements of business domain. Next are process classes. As the name suggests, they will help us to implement lower level business abstractions required to fully manage and business domain classes. Point number 4. Persistent classes represent data stores such as database that will persist beyond the execution of the software. So the word persistent means storage. So persistent classes will represent data store that will persist beyond the execution of the software. That is, data sometimes is released once the executed program, but here it remains permanently in the data store. And system classes. So these system classes implement software management and control function that enable the system to operate and communicate within its computing environment and outside world. So as the name suggests, system classes help us to implement the software, okay, manage it, control the various functions, and see that the system will operate and communicate within the computing environment and outside world. So today we have taken the last aspects in the design classes. Okay, so please write them in your notebook, study. If you got anything, you can call me. Thank you.